Next problem is related to kinetics of the particle, problem 13-7 of the book. In this problem there is a block which is moving with a speed of 4 feet per second. The force is variable, it is 8t square. We have to find the velocity of the block when it moves to s equal to 30 feet. The coefficient of kinetic friction at the surface is 0.2. Since the force is variable, it can result in change in velocity or acceleration. So we have to find when the block moves 30 feet, what will be the velocity. You can see the forces on the block. One is the applied force. Applied force is 8t square. Then there is weight of the block, which is 10 pounds, and there will be normal reaction, and due to friction effect there is friction force. The coefficient of friction is given, it is 0.2, and normal force is n, so friction force will be equal to 0.2 n. Then we sum the forces in x direction. In x direction there is applied force 8t square, and there is friction force which is 0.2 n. This will result in acceleration. So mass is 10 over 32.2 multiplied by acceleration in x direction. Then we apply the force balance in y direction. In y direction there is no acceleration, the motion is in x direction, so ay will be equal to 0. So after solving the two equations, or after solving the first equation, we get acceleration ax equal to a equal to 33.22 multiplied by 8t square minus 2. Now from the second law of motion equation, we are getting data of normal force n equal to 10, and then we are getting acceleration in terms of time. But we have to find the velocity when distance is 30 feet. So we have to apply the other equations to get the required output data. So we use the kinematic equations. According to kinematic equation, integral dv is equal to acceleration multiplied by dt, that is a equal to dv over dt, or integral dv is equal to integral a dt. Instead of a, we write 3.22 8t square minus 2. The initial velocity is 4, so lower limit is 4, the upper limit is variable. So after integration and solving, we get velocity in terms of time. Now again the data is given about the distance covered, which is 30 feet. So this means we have to obtain an equation which is for position. So v equal to ds over dt, or integral ds equal to integral v dt. Instead of v, we put this equation which is in terms of time, 8.59 t cube minus 6.44 t plus 4. So we put in this equation, instead of v, we put this relation in terms of time. After integration, we will get s in terms of t. The value of s is given, it is 30. So we have to solve this equation. After solving, we will get time equal to 2 seconds. Now this equation cannot be solved in a simple manner, so we can use some we can use some calculator which can solve this equation and get the real value of time. Or we can have some advanced method which we have studied in the topic of calculus to solve this problem. So by solving the equation, we will get time equal to 2 seconds. We can substitute time in this relation. We will get velocity at time equal to 2 seconds. So the solution is 60 feet per second. Next problem is 13-80. In this problem there is a pendulum bob which is moving in a vertical plane, and its velocity is 8 meters per second when theta is equal to 0 degree. The pendulum bob is moving in counterclockwise direction, so it is moving upward, and we have to find the initial tension in the cord, that is when theta equal to 0, and then we have to find the tension in the wire or the cord when theta is equal to 30 degree. Neglect the size of the bob. This means we are considering the particle, so the size of the bob will not be considered. So you can see various directions. Since the bob is moving in a circular path, it is convenient to use normal and tangent system rather than the rectangular coordinate system. So for a particular angle, this is the direction of normal, direction of chord is direction of normal, and tangent to the normal direction is tangential direction. At a certain instant, at any instant, the weight of the bob will be downward and direction of tension will be towards the normal. So we will be solving this problem of kinetics in the normal and tangential direction. We apply the equation of motion in tangential direction and then in the normal direction. When we solve in tangential direction, there is only one force, and that is the component of weight. So weight is equal to mass into g. Mass is 2 kg and g is 9.81, and the component is cos theta. Since we are measuring the normal direction with respect to horizontal, the direction of chord or the angle of the chord is theta. So angle between weight and tangent will also be theta. So the component of weight which is in the tangential direction is weight multiplied by cos theta. And since weight is opposite to the tangential direction, we have a negative sign. The tangential direction is positive in the direction of motion. The direction of motion is counterclockwise, so the direction upward is positive. Then mass is 2 and acceleration in tangential direction is 80. Then we apply the equation of motion in normal direction. In normal direction we have tension in the chord which will be positive, and then we have the component of weight. The component of weight is weight, mass into g multiplied by sin theta. In this figure the angle between weight and normal is theta. So when we take sine component, we get the component of weight in normal direction. Sum of all the forces is equal to mass into acceleration. The acceleration is normal acceleration, and from the basic formula the students know that normal acceleration is v square over rho. The normal acceleration is due to change in direction. So v square over 2 is radius of curvature, or it is the length of the chord. Length of chord and radius of curvature are same. So this is our equation number 2. In this equation we have three unknowns. Tension is unknown, velocity is unknown, and angle is unknown, but we have to find the tension when theta is 0 or 30. In that sense it is known. Now in the problem it is given that we have to find the initial tension. So initial tension is for the case when theta is equal to 0. If we substitute theta equal to 0 and initial velocity is also given, it is 8. So initial tension will be equal to 64. The initial velocity is given in the problem, it is 8 meter per second. So initial tension is 64 pounds. In addition, we have to find the tension when theta is equal to 30 degree. In that case velocity is unknown, so we have to find the velocity so that we can find the tension at theta equal to 30 degree. Now we apply the equation v dv equal to at ds, because since we know the angle, we can find the displacement, we can find the distance covered, and we need the value of velocity. So it is simple, it is more convenient to use v dv equal to at ds formula rather than v equal to ds over dt or a equal to dv over dt. So we directly use this formula. ds is distance covered and ds is equal to r d theta. The length of the chord is 2, so we replace r equal to 2, and from equation at is equal to minus 9.81 cos theta. So instead of ds we write 2d theta, and instead of at we write minus 9.81 cos theta. So from equation number 1, at is equal to minus 9.8 cos theta. The limits are 8 and v. 8 is the initial velocity, initial angle is 0, final angle is 30. So by solving we get equation in terms of velocity and theta. If theta is 30, then velocity square is 44.4, and if we take root, velocity will be about 6.5. But we have to put velocity square in equation number 2. Theta will be 30, velocity square will be 44.4. By substituting, tension will be equal to 34.6. In next problem there is a assembly line, and on the assembly line the cartons of mass 5 kg are moving. and the speed is constant, it is 8 meter per second. We have to find the smallest radius of curvature for the conveyor so that the cartons do not slip. If the radius of curvature will be further less, then cartons can slip due to the absence of significant frictional force. The coefficients of friction, the static friction is given, coefficient of static friction is given, the coefficient of kinetic friction is given. The coefficient of friction is between carton and the conveyor. Static friction is 0.7 and coefficient of kinetic friction is 0.5. Again, we can use normal and tangential analysis. Because the conveyor is moving in a circular path, the cartons are moving in a circular path, we can use the normal and tangential analysis. Now, when we are solving in the normal and tangential method, then the third direction is binormal direction. And in the topic we studied that in the binormal direction there is no acceleration. There will be forces, but forces will balance out, but there will be no acceleration in the binormal direction. When we are using the normal and tangential component, the motion, the kinematic parameters are simply defined with the help of normal and tangent. But when we come to kinetic analysis, we need additional direction, which is binormal direction. So binormal direction is in the vertical direction. In the vertical direction there are two forces, one is normal and other one is weight. Normal reaction and weight. Weight is acting downward and normal direction is opposite. So weight can be determined, the mass is 5 kg multiplied by 9.81 will give 49.1. Then we calculate the friction force. Friction force is coefficient of friction multiplied by normal reaction. There are two coefficients of friction given, one is coefficient of kinetic friction and other one is of static friction. Since static friction is higher, we can consider higher friction factor, coefficient of friction, for the safety purposes. The coefficient of static friction can occur when the object starts moving, and once the motion is started, the coefficient of friction is kinetic friction, which is 0.5. So we can assume a value of 0.7 for the purpose of the safety. We consider a higher friction force. So higher friction force, higher coefficient of friction will give a value of 34.3. Then we apply the equation of motion in normal direction. In normal direction there is friction force and there is mass multiplied by normal acceleration. The friction force will occur in normal direction as well as tangential direction. The normal reaction is in vertical direction, so friction force can be towards normal. Normal is towards the center of the axis, it is towards the axis. This will be the normal direction and this is the tangential direction. So there is friction force in tangential direction, there is friction force in there can be friction force in normal direction. Since the carton is moving with a constant speed of 8 meters per second, there is no friction required. There is no acceleration in tangential direction, so there is no friction force required to balance it. But since the carton is following a curved path, there is normal acceleration, and for balancing the normal acceleration, the friction force comes into effect in the normal direction. So friction force is 34.3, mass is 5 kilogram, and velocity is 8. By solving this, we get radius of curvature as 9.3. So this is the minimum radius of curvature. If the radius of curvature is increased, if the radius of curvature is decreased, then we need more friction force. And if we do not get more friction force, then carton can slip from the conveyor. Next problem is 13-68. The car is moving on a hill, and the surface is such that it follows the shape of parabola. The weight of the car is 800 kilogram, and the driver maintains a constant speed of 9 meters per second. We have to find the resultant normal force and resultant friction force at point A when it reaches point A, and obviously for the particle we have to neglect the size of the car. The equation of parabola is given y equal to 20, 1 minus x square over 6400, and at location A the value of x is 80, and when x is 0, the height of the hill is 20 meter measured from the reference point. Again, we can determine the normal and friction force using the normal and tangent method. But here the radius of curvature is not given. Since it is a parabola, the radius of curvature can vary from point to point. It can vary at various locations. We are interested in determining the normal and tangential force when x is equal to 80. So we will determine the radius of curvature at a point where x is equal to 80. From the mathematics background, we can prove that radius of curvature is related to the slope, and it is related to the second slope d2y over dx square. And if you find these two derivatives, we can substitute and we can find the radius of curvature at a particular instant. So we differentiate this equation of parabola, we will get minus 0.00625x, and when we differentiate second time, we will get minus 0.00625. So we will substitute x equal to 80, and this is constant. We substitute all the values, and we get radius of curvature equal to 223.6. So this is the radius of curvature at the particular point where we have to find the friction force and normal force. Now for the analysis purpose, we have to find the angle at location A. The tangential direction will be obviously tangent towards downward. This is the tangential direction. It will be at some angle. It will be at some angle with x. We can find the angle using first derivative dy over dx. Then we take tan inverse. X is equal to 80. We substitute x equal to 80. Then we take tan inverse, and we get 26.6. So 26.6 is the angle between tangent and x-axis. This is tangential direction and this is x, so difference is minus 26.6. You can see the figure at the instant where we have to perform calculations. This is the location of the car. This is tangential direction. Between tangent and x-axis angle is 26.6. Weight will be acting downward, and normal will be towards normal direction, and it is perpendicular to the surface. Friction force is tangent to the surface. So there are three forces. One is friction force, other one is weight of the car, and the third one is normal reaction. We apply the equation of motion in tangential direction. In tangential direction we have friction force. Friction force is opposite to the tangential direction. Then another force in tangential direction is the weight of the car. So weight of car is mass, which is 800 kg, g is 9.81, and the component of weight in tangential direction will be obtained by multiplying with sine 26.6. So by solving, we get friction force equal to 3.51 kilonewton. Then we apply the equation of motion in normal direction. In normal direction there are again two forces. One is normal reaction, which is N, and there is component of weight. Component of weight is 800 multiplied by 9.81, and then we take component of weight in normal direction. Since there is angle of 26.6 between x and t, there will be an angle of 26.6 between weight and normal. So component of weight subtracted by normal direction is equal to 800, which is mass, and velocity as given in the problem is 9. The speed is constant, it is 9 meter per second. We substitute velocity equal to 9, and radius of curvature is 223.6. So this will give a value of 6.73 kilonewton. In this question there is no acceleration in tangential direction. The reason is that the speed is constant, and when speed is constant there is no tangential acceleration. So here tangential acceleration is equal to 0. So this is the calculation of the forces when x is equal to 80. The value of the value of the forces will depend on x location. If suppose the x location is 40, then we have to solve the entire problem by substituting x equal to 40. The radius of curvature will be different at location x equal to 40. This will vary the radius of curvature, and the variation of the radius of curvature will change the normal acceleration. When it will change normal acceleration, then the value of the normal reaction can change.